Well, it's 10:30. I think we can talk about the bids for the boiler replacement now.
Yes. This on vibrate. Good morning, gentlemen.
Morning. Morning.
Brought 3 copies with. Basically, I give you 2 different options. 2 different options for boilers. One of the options I don't have the glossies for, but it's a Weil McLean aluminum cast type boiler heat exchanger. And the second one is a Prestige. This one's a lot more expensive boiler. Basically, the bid includes everything except the asbestos abatement, getting rid of the asbestos, which will be done by somebody else. We'll come in, we'll take the boilers out, we pipe the new boiler in, install the new boilers. The cost for the Weil McLean cast iron sectionals is $46,953. That includes the removal of everything down to the boiler room, all the associated piping, the steam piping. We got to get rid of the steam heat exchanger. Basically, the way the existing boiler works, it's a big steam boiler. It produces steam. The steam comes out of the boiler, it goes through a heat exchanger. And the building heating loop goes through a heat exchanger as well. So the steam is what heats the building water. It's kind of an inefficient way to heat a building. You've got to produce steam, use the steam to heat the water. So what we're proposing is to get rid of the heat exchanger, get rid of the steam boiler. We'll put these small modular boilers in. With these boilers here, this is a more expensive option. We'll get 2 of these boilers. And with the Weil McLean, we'll have to go with 3 boilers. Even though we're going with 3 boilers, it's less money, but the triangle tube is a little bit better boiler. It's a little bit less susceptible to scaling, so we get scale in the boilers. The aluminum Weil McLean boiler doesn't handle that quite as well as the cast iron. These cast iron boiler, or the stainless steel boilers are self-cleaning, so they start to scale out. The boiler kind of cleans itself. So,
what's the expected life expectancy of both?
Both will be pretty much the same if we treat the water, which would be the boiler. The water in the system is going to have to be treated. So once a year, and Mark already has that done. So once a year, the water needs to. Somebody needs to come in and test the water just to make sure that our pH is right. Our total dissolved solvents in the system is not too high, and the total dissolved solvents is the scale line, anything that may be in the water. So with either boiler, if you maintain the water, 25 years is an easy number to attain with these. This triangle tube boiler is a 95% efficient boiler. It's the highest efficiency that you can find in a boiler nowadays. The Weil McLean boiler is a 92% efficient boiler. Both of them are outstanding with their efficiencies. They're considered condensing boilers, which means they run at such a high efficiency that moisture is within the flue gases condensed inside the boiler, so we have to drain it to a floor drain to get rid of the moisture. Compared to the system we've got, that current boiler runs it's running on low fire right now. It's 1,000,005 BTUs. So that's what the actual input into the boiler is. So based on that, the boiler's running 80% efficient. We're losing 300,000 BTUs up the stack. It's doing nothing but wasting energy. So with these boilers, for the most part, what we're losing up the stack with the existing boiler would be enough to heat this building most of the time, just with what we're losing up the stack. So
the replacement boiler system, will we still use that same chimney that's on the building?
no, the chimney that's there, you still have to keep the chimney in place because the lower boiler is being piped into that. The boiler that's currently in there, the one we're going to replace, that hole will have to be filled and capped, and then the lower boiler will still utilize that.
The lower boiler, what do you mean?
And the new part.
For the other offices, yeah. Yeah, we'll get rid of that. And there's also a big duct that comes up to the roof that acts as the combustion air intake duct that brings combustion air into the building that allows the burner to burn that. That will be capped off, and the PVC pipe venting will go up through that chase and exit the roof on the lower roof down here on the new addition. So we have to bring 2 pipes in with the cascade pipe per boiler. One will be the exhaust going out, one will be the intake coming in. So the new boilers will not actually need combustion air from inside the space, they'll suck it right from the outside. This is where we get their combustion air from. And a big part of this is just getting rid of that old boiler. We cut out in little pieces, and I've got 3 to 4 guys for 4 days just cutting and tearing stuff out. There's a lot of iron in that boiler. So,
How big of a mess is that, and how will that interfere with the daily?
I was telling Mark that if it's all right with this courthouse, we'd rather do that on a Saturday, because we're going to produce some smoke. We'll put exhaust fans and blow it backwards up that existing fresh air intake, and we'll exhaust the room, so we'll get rid of a lot of the smoke and dust and debris up to that. But we'd rather do that on a Saturday, because otherwise it's going to be a lot of hammering, pinging, and they're going to smell the smoke in the building. As well as we exhaust that room, someone's still going to get out.
Sure.
So if that could be done on a Saturday, that would be a lot better time to do it.
Now, do you hang like plastic curtains in the halls and?
What we'd probably do is just hang a curtain over that doorway in the boiler room.
Okay.
If we can get an exhaust fan large enough to evacuate that room, it should draw that room into a negative pressure. But so I'm hoping that we won't get much smoke out of the hallways. But, that's probably how we'll do that. So by drawing that room into a negative, hopefully nothing will escape out into the halls. So. Warranties on both heat exchangers, I believe, is 10 years. I can get you glossies on the Wild McLean. They're both exceptional boilers. Wild McLean's been in business for, that old boiler up at the church is 45 years old, I bet. That's a Wild McLean, so they've been in business for a long time. Triangle Tube, they've been around for a long, long time. They both have very good track records, so both are exceptional boilers.
You talked about the Wild McLean, how much higher is the other one?
The Triangle Tube?
Yeah.
About $5,000 higher. The Wild McLean will get 3 boilers out of that. That's the lower bid. We get 3 of those versus 2 of these for $5,000 more. The difference in efficiency, 93%, isn't that great. That's leaps and bounds above what you actually have now.
4,600.
And one of the big cost differences with these is they've got it's a hydro separator and it's a manifold that comes pre-piped from the factory. These boilers have to hang on that pre-manufactured pipe header that's on the bottom of the boiler and behind the boilers. Plus they've got a huge hydro separator tank that hangs on the end. So all that needs to be manufactured from the factory, then it's assembled on site. Whereas with the Wild McLean, we don't have to have that, or we just have to do a lot of piping. So basically we'll build the same thing in-house, is what the Triangle Tubes would need.
How much space do these things take up?
The Wild McLeans are approximately 30 inches wide by 30 inches deep by 4 foot tall.
There's 3 of those?
3 of those.
Now they sit right next to each other?
We'll have a foot between them.
Yeah.
And these, when they hang on that pipe, there's only about that much between them. So it, you'll have a lot more storage down there. They won't take up much space at all. And both of these systems have an outside air reference. So we'll put a temperature sensor that senses the outside air temperature, and that will reset the boiler loop temperature. So on a day when it's 50 degrees, you don't need 180 degree water circulating through the system. So it'll reset back to, say, 120 degrees. Whereas it's 0 outside, and we'll bump that heating loop up to 180 degrees, because that's when you'll need your maximum heat available. Both boilers modulate, so when they fire off at 50%, and then the microprocessor inside the boilers figures out where they need to be as far as staging. So they can run anywhere from 0 all the way to 100%, and anywhere in between.